Mind your decisions, I'm Presh Talwalkar. A ladder and a cube are in a room. Place the cube along the wall and then rest the ladder along the wall so that it is just touching the side of the cube. For precision, think about the ladder as a line segment. If the ladder has a length equal to 4 and the cube has a side length equal to 1, what is the distance between the top of the cube and the top of the ladder, denoted by the variable y in the following diagram? I thank Nathaniel M., Mark L., and Per T for the suggestion. For a challenge, find an exact answer for the general case where the ladder has a length L and the cube has a side length C. Pause the video if you'd like to give this problem a try, and when you're ready, keep watching to learn how to solve this problem. So how can we solve this problem? We have a ladder with a length of 4, a cube with a side length equal to 1, and we want to solve for the distance y. It seems simple, but it's quite complicated. The solution I'm going to present is from the user Blue on Math Stack Exchange. I thought it was a very elegant solution. We'll get started with the general case. Suppose the ladder has a length of L and the cube has a side length C. We want to solve for y in terms of L and C. To do that, let's label some more parts of this diagram. The other side of the cube will also have a length of C, and we'll label the horizontal distance between the ladder and the cube as x. Now we're going to do a neat little trick. We're going to copy this diagram 3 different times and construct a square. This is going to create a clever geometric solution. We're now going to put this diagram to the side. Let's connect the 4 corners of these internal squares, creating another square. Suppose this square has a side length equal to w. Now let's label the area of this triangle, where one side length is equal to x, as capital X. We'll label the other triangle with a side length y as capital Y. We'll label these parts in other parts of this diagram. Now suppose this triangle has an area equal to z. By symmetry, these will also have areas equal to z. And just so we don't get lost, the square that consists of the 4 ladders we'll put in blue. Now let's calculate the area of this green square. Well, one way to calculate its area is that its side length is equal to w plus c, so its area will be the quantity w plus c squared. Another way is we'll sum up the areas of the rectangles inside of this square. Here we have a square with an area that's equal to c squared. We then have 2 rectangles as follows. This is one rectangle and this is another rectangle. We have 2 x terms and 2 y terms, so we have 2 times the quantity x plus y, and we have 2 z terms, so we get plus 2z. We also have this square, which has a side length equal to w, so its area will be w squared. We can simplify this formula a little bit. Consider this rectangle. 1/2 of its area will be equal to z, and 1/2 of its area will also be equal to x plus y. Therefore, x plus y is equal to z. We substitute that into this term x plus y, and it will become 2 times z. We then group the z terms, so we have 4 times z. We now simplify this formula one more time. We have 4z plus w squared. What's that equal to? It will exactly be equal to the area of this square, which has a side length equal to L. Therefore, 4z plus w squared is equal to L squared, and we substitute that in. We now have a very simple formula. We take the square root of both sides, and we'll take only the positive square root because we're considering positive lengths. We then subtract c from both sides, and we get an equation for w in terms of the known values of c and L. We now make one observation about w. W is exactly equal to the side length of this square, which is equal to the quantity x plus y. So we have w is equal to x plus y, and we want to solve for y. To do that, we'll consider these triangles. Because the ladder has a constant slope, these 2 right triangles will be similar. Therefore, the ratio between the horizontal leg and the vertical leg will be equal in both triangles. So we have x over c is equal to c over y, which means x is equal to c squared over y. We substitute that into the equation where w is equal to x plus y. We now multiply both sides of this equation by y, and then simplify this. We now have a quadratic equation in y. We can use Brahmagupta's quadratic formula to get the following two possible values. Now we have a plus and a minus. Notice the plus will be a larger term, and this will correspond to y, which is the vertical longer distance. The negative term will actually correspond to x, which is the horizontal distance. So we'll separate these two terms. We've thus figured out a general formula for y. How does this work? In our original problem, c was equal to 1 and L was equal to 4. So we substitute that into the formula for w, and we get that w is equal to -1 plus the square root of 17. We then substitute that into our formula for y, and we get the following equation. We simplify this equation a little bit, and we get the exact answer for y. This is approximately equal to 2.76, and that's the answer to this problem. Thanks for making Mind Your Decisions one of the best channels on YouTube. As always, thanks for watching, and thanks for your support.